All right, welcome everybody to week 4, day 3. We've got a long weekend coming up, so there's no class on Monday, but be sure to do your competency exam. The competency exam is due on Monday. You're going to have the side books due on Wednesday, and you're going to be getting a new homework assignment today. It will be due on Friday, so plenty of work coming up. I want you to have fun over Labor Day weekend. The quiz for today is a single question. I don't want to stress you out too much. But you should be on top of all of that. So the competency exam, I should probably talk about that a little bit. This is how I do midterms and finals. In other words, there are no midterms and finals in this class. Instead, there are these things called competency exams. You can see it right here. Okay, due on September 5th. And it's 4 questions. It's 3 multiple choice questions. It is 1 open answer. You have to write a whole program. 1 point for each. If you get a 3 out of 4 or 4 out of 4, you pass it. And if you get 3 out of 4, I bump your score up to 4 out of 4. So you don't need to worry about retaking it to get a higher grade. If you fail it, in other words, getting a 0, 1, or 2, then another branch's competency exam will go up next week. And you can take it again, and the highest score, wins, so to speak. So for those of you that pass it the first time, I'm inevitably going to get questions like, hey, do I have to take 2? And the answer is no. Don't. It's more work for me to grade, and you've already passed it. Just ignore it. You get the highest grade counts across the 4 of them. So it'll probably pop up in your Canvas. If you've passed, take 1, just close it. Like don't take it. Because I have to go through every single line of code that people type in there, and it's a lot. There's like 90 students. So if you pass it the first time, just go easy on me and just don't take it again. Okay. Or if you do take it again just to see the questions, don't do the program. Okay. So how difficult would you say it is? The questions are similar to the quiz questions, but I deliberately make them a little bit harder than normal. So they're not supposed to be easy, give me questions that you can just click on, whatever. You have to think about them a little bit. They are designed to show you understand the concept. And so, for example, I might give you a bunch of if and else statements with like, this branch prints out Harambe and this one prints out, seashell. And I might be like, what input will result in seashell being printed out? And there's ones like if it's less than 5 and the other one's greater than 2 and all this kind of stuff. So you just kind of have to look at it a little bit. Okay. Kind of like the side books work. Yeah, it's not noticeably different from the quizzes you've been doing in class. They're just kind of like on the harder end of the quiz questions you've been doing in class. So, Min Crowley is going to be doing a study session for the branch's competency exam tomorrow. And, the rule is if you fail it the first time, you can take it again the second time, no problem. If you fail it the second time, then you need to go and make an appointment with a tutor, such as Min Crowley or one of the other tutors, and they will walk you through branches. The goal here is not to fail you or be punitive. The goal is to make sure you understand them. Because if you don't understand an if statement now, you're probably not going to understand it by the time you get to second semester computer science. It will be a train wreck on top of a train wreck on top of a train wreck. So we really, really want to make sure you understand the core concepts of computer science. That's why this class is structured this way. It's not designed to like filter out the unworthy. The goal is that for any student who wants to put in the time and effort to learn, you will learn and you'll come out of this class knowing the basics of computer science really well. Okay? And if you don't do the Zybooks, I get it. There's a lot of work there, but you need, at a certain point, you just need to put in the time, right, to learn. There's no substitution for practice. Okay? So, all of the points are in for times table, and then the next one you'll be getting today. That one is going to be called triangle testing. It's similar to the lab work that we did last 2 weeks ago, I think. We were doing a little bit of lab time for triangle testing. And basically for this one, you're gonna get some input and you're gonna identify what kind of triangle it is. And this will be just like a little half-point assignment here. We do on 9th, 12th. Okay, So that's coming up, and we will talk about that later. But we got some important stuff to go over today. There's two main learning points that we need to go over today. The first is the notion of plus plus and the difference between plus plus and plus plus. So, let's see. Turn my RGB lights on. There we go. Okay. All right. So let's talk about learning point number 1. The difference between plus plus and plus plus. Okay. This is actually how I got hired at our college here. They give us 5 topics that I could lecture on. I decided to lecture on how to add 1 to a number. And they're like, what? And I'm like, yeah, this will take us 15 minutes. Because there's actually some intricacies. So x plus plus, if you do that, this is the same thing as saying like x is equal to x plus 1, right? We all know this. Or, x plus equals 1. Now, the weirdness comes in. Uh-oh. Is Putty doing the thing again? Putty's doing the thing. All right, let me bail out of Putty. You always on top. All right, let me relaunch Putty. There we go. So the difference is if you embed this into a bigger expression. So this also means x is equal to x plus 1, and it also means x plus equals 1. Like all 4 of these things are kind of the same if you put it on its own line. For example, if we have int x equals 10, and we do x plus plus, we see out x. What value is going to get printed to the screen here? Yeah, it's going to print 11. Now, what if I switch this with this? What number is this going to print to the screen? Yeah, also 11. Good. Okay, so what's the learning point for today? The learning point for today is what happens if you embed it within a bigger command. So what is this going to print to the screen? It can print 2 numbers. Ten and 11, 10 and 11, 11 and 11. Got a lot of votes here. Okay. Let me run it. Get your votes in now. 11 and 010. Okay. 10 and 11. So you might be saying, like, why is that 10? Why did that print 10? Because let's talk about what x plus plus means. X plus plus means return the value of x, and then after the statement runs, add 1 to x. Okay, this is called the postfix operator. All right, and so this is going to return the value of x. It's as if I had written this, kind of. So it returns the value of x, it gets printed to the screen, and then after the statement runs, it adds 1 to it. Okay? Now, what about this? Plus plus x means the same 2 things happen, but in the reverse order. So it means add 1 to x, and then return the value of x. This is called the prefix. Prefix increment. Okay. So if we did plus plus x, it adds 1 to x first, then returns 11 as the result. So what is this going to print? 11, 11, 11, 11, 11, 11. Very good. Okay. Good, good, good. So what if I did this? What is this going to print to the screen? Using your knowledge. Got 3 numbers down. Okay, so if we take it one line at a time, x starts off equal to 10. When we get here, it increments the value of x to be 11, and then it returns 11, so it prints 11. Here, it returns 11, then increments it up to 12. So it's going to print 11, 11, and then 12. Okay. 11, 11, and 12. Okay, cool. All right. Take it back. Take it back old school a little bit. I don't need the parentheses, but... All right, so what's this going to print? I mean, obviously, right? This is just x plus 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 x, right? Like, it's all very obvious. I don't think I need to explain this. (21, 22, 21, 22, 10, and 11). Now, it's not going to print out 2 numbers. There's only 1 number in that parentheses. Right? 23, 21, 22, 22 it is. Okay. So why is it 22? The plus plus probably increments it first up to 11, and then it's going to add 11 and 11 to get 22. And then what if we see out the x here? We get 12. Do you see why? No? So before this, this value is 10, right? So the plus plus x increments it to 11 before this expression is evaluated. An expression, by the way, is anything that can go inside a pair of parentheses, a statement, anything that can't. How about that for a simple rule? Okay. So this is an expression because you can wrap it in parentheses. So the plus plus x increments it to 11 before it does any math. So then it's going to be 11 plus 11 is 22. And then after it runs, remember spaces don't matter, then after it runs, it's going to increment x again. After the statement runs, and it goes from 11 to 12. So the value here is 12. That makes sense, Fina? So we got 2 different increments, one that happens before, one that happens after, and we get 22 and 12. And this is how I got hired. I explained to a bunch of people, most of which weren't computer science majors, how to add 1 to a number, starting with the very simplest, adding 1, and eventually having them like decipher these things. By the way, you should not write code this way. It is technically undefined behavior. And so undefined behavior, UB for short, UB, undefined behavior, means that the compiler can do anything. So in this case, the compiler behaved the way that we thought it should. There's no guarantee of it. This is actually undefined in the standard. You should not be writing code this way. This is what we call no, also known as a job security code, because it can't fire you because nobody else can read it. So if you have undefined behavior, the compiler can technically do anything it wanted. It could have returned 420 there. It could have returned -1. It could have deleted all of the files on your file system. It could have played the Macarena. It could display an image of Mike Tyson biting Evander Holyfield's ear off. Whatever. You know what I mean? It's all fair game. When you have undefined behavior in your code, the compiler can literally do anything, and it is standards conformant. So you can actually, people like hypothesize like some sort of especially vicious compiler that whenever you have undefined behavior, it just wipes your file system, right? So it's like hardcore mode in a roguelike video game. You get one shot, and if you screw up, boom, wipes your system, start over, reinstall from scratch. So if you want, I can turn hardcore mode on the server. Every time your code doesn't compile, it deletes a file. We could do that if you want. Just randomly deletes a file every time it doesn't. Caesar's voting yes. All right, let's do this. Okay. Wait. No, thank you. All right, sir. All right. Yeah, I think that's a pretty good overview of that. Okay. So that's learning point number one. Yeah, and so mixing lots of plus pluses together is undefined behavior. Okay. So there's a notion called a code sequence point and things like that we don't need to get into. Basically, the upshot is x plus plus by itself is a yes. Saying x plus 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 x is a no. How about that? That as a general rule of thumb, right? For coding, this is okay. Everyone understands it. This will make people's eyes bleed. Okay. X plus 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 plus. This is valid C++. This is the same thing as if I had written x plus 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 x plus 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 x plus x plus plus. Or white space doesn't matter. So yes, you can have 3 pluses in a row. Can't have 5 in a row, unfortunately. I tried. But you can certainly have 3 in a row. So x plus 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 x plus 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 x plus x plus plus. There you go. It all makes sense. So it's chaotic, evil. Okay. All right. So there's this programming language. Yeah, I know exactly the programming language that you were talking about. Min Crowley actually mentioned it earlier in class. I'm not going to read it out loud in case my daughter watches this video at some point. But yeah, this is the language. These are the only things allowed in it right here. This is it. Your whole code's going to be made out of these things. And then, so if we get hello world, here is hello world. Okay, it's all very clear. I don't think I need to explain this to you, right? We should. I think it's all just very obvious what is happening here. So, there you go. Yeah, that's a good one. That's a. I mean, yeah, sure. Okay. So that's hello world. I think we can all see that as hello world, right? So, here's rot 13. You know, adds 13 to every letter. Yeah. Okay, so yeah, pretty easy. I think that's really more CS1 stuff, not really CSI 40. It's on Steam. That's really cool. Oh, it's just a guide. Okay, mostly negative. Yeah, that's fair. What is the Arnold esoteric? So there's a programming language where it's all like Arnold Schwarzenegger quotes. It's showtime. Talk to the hand. Hello world. You have been terminated. I lied. No problemo. You have no respect for logic. Stick around, chill. Where's get in the choppa? There we go. Get to the choppa. Yeah, this is a real programming language. You can program that. There's one that's for Shakespeare. Like, all of it is like Shakespeare quotes and things like that. Okay, anyway, that's all we're learning today. What we're learning today is functions. Yeah, big topic. This is our final 6 out of 6. So after you guys understand, yeah, true. Like if somebody does corporate spy you and they see this, they're just going to give up. That's it. An anti-theft device, right? It's like painting your car like a garish pink. Like nobody wants to steal it, right? It draws too much attention. I don't know. Okay. So we're going to learn functions today. This is a huge topic. This is the final major learning point for the semester. We're going to get to classes towards the end of the semester. But classes are just ways of reorganizing the other 6 things. We're going to learn vectors, which again are just more variables than regular variables. So this is it. Once you know variables, algebra, conditionals, loops, and functions, and input and output, you can basically make any program. It just takes practice. Okay. So here we go. So let's talk about this. This out. Learning point number 2, functions. So everybody here is taking algebra, right? Yeah? Oh, hope so. Hopefully you've had at least a little trig. Okay. I think. Good. I hope. I don't know. Okay, so you should all know like f of x is equal to like, I don't know, x squared plus 3 or something like that, right? Like, you all know what this is doing, right? It's like things. Not too hard. Okay. So let me show you how to do that in C++. Okay. Not all functions in C++ are like algebraic functions, but it's a good place to start. Okay, so I'm going to call the function a few times. So how do you call a function? You've been doing this a little bit, so you can have float bob is equal to f10. So when you call a function, I'll get to this syntax for making a function in a second. When you call a function, you give it its name, and then the parentheses are essential. The parentheses tell C++ this is a function, and you pass parameters to it. Not all functions have parameters. If it didn't have a parameter, it would look like that. Just f open close, like s.size doesn't have any parameters on it. So this is, when we say Bob is equal to f of 10, what happens is that when we get to this line of code in main, it pauses main, and then it jumps up into the function named f. And it does some computations. It's going to square x, it's going to add 3 to it, and then it's going to return the value. And when you return a value, it's as if this line of code is as if you had written float bob equals 103. Right? So where you had f of 10 before, it's as if you had written 103 there. You guys understand? So like anywhere you could put a number, like 103, you could put f of 10, and it will swap out when the program runs. Like the program runs, it'll do some computations, and then when the number comes back, the return value comes back, it kind of sits there in the place of the function. Do you guys understand this? So basically anywhere you could put 103, you could put f of 10, right? So x squared, 10 squared is 100. 100 plus 3 is 103. Okay. So could you do this? F of 10 equals Bob. Is that legal? Because remember, this is basically exactly the same as writing, no, it's not. It's basically exactly the same as writing 103 is equal to Bob. And can you change the value of 103? No. Right? This is not Fortran. So Fortran's a programming language. And you can change a 0 to a 1 if you want. Or you can set the value of 103 to be 12 if you want. Yeah. I mean, think about how terrifying that is, right? Like you said 0 is equal to 5, and you like see out 0 plus 0. And like output's 10. Like, do you understand how terrifying that is? Like, can you imagine trying to track down that bug? Like you're outputting 0 plus 0 and you get 10. Like, what? Like what? So fortunately, C++ does not allow that. You cannot change the value of a number. Okay. And so you cannot do f of 10 equals 5 because that's as if you had said 103 equals 5. No, can't do that. Okay. It's like Cthulhu level of nonsense, right? Like I changed the value of 0. What? Okay, so yeah, none of that's legal, thankfully. Okay. So what is this line here going to print? What is this line going to print here? You do the math in your head. 0 squared plus 3. Yep, it'll print 3. And so do you see how, like, you know, you can put it inside of a cout statement, and that's as if I'd written 3 there. Or you can put it here, or you can say, you know, you can maybe call it multiple times. Plus f of 1. Right, so this would be 103 plus 4. So this would be 107. Do you see that? So you can call it multiple times. And the reason, and that's why we do functions, okay? So we use functions to avoid repeating ourselves. Okay? There's something called the dry principle. Don't repeat yourself. Okay? I'll say it again. Don't repeat yourself. Don't repeat yourself. Don't repeat yourself. So don't repeat yourself. Okay? So don't repeat yourself. We could have like done all of this like this, like cout 0 times 0 plus 3, and I could have done 1 time, you know, plus 3, and 3 times 2 plus 3, and you guys see what I'm getting at here? Like, you know, you don't need the function, right? You could have just done it the hard way every time, but anytime you find yourself repeating a code block, that's a good sign to you. You should put it into a function. Anytime you find multiple chunks of code doing the exact same thing, that's a sign, okay, I need to put that into a function, suck it up there, and then do a function call rather than repeating the code down here. Now you might notice that the function is above main. You can put below main, but not today. I'll show you how to do that later. Yep. How do you get multiple functions? Yeah, you don't have to name your functions f. This isn't math. So I could have called this one like, I don't know, square in 3 or something like that. Probably put some underscores in there. You can call your function anything you want. And f is, I just called it f because, you know, math, right? Everything in math, all the functions are called f. And if you've already got an f, it's g. And if you got a g, it's an h. And the parameter you pass to it's always x. Once you have 2 parameters, then it's x and y. I don't know. I don't have any good answers for you. But in C++, you always want to give your functions like good names, you know, like that kind of explain what it's doing. So, yeah. All right. So if you want to have multiple functions, you just have different names. So like if I wanted to have a different one that did, so this one does x squared plus 3. If I want to have another one that computed like the sine of x plus the cosine of y. And I haven't gone through the syntax yet. Float of, I don't know, sine, cosine, something like that. Float x, float y. I could do it on one line. I'm going to do it in 2 lines just to show you don't always have to do it on one line. So float return value is equal to the sine of x. Ret val plus equals the cosine of y. Return ret val. Need to include cmath up top here. Okay. Yeah. Okay. So yeah, hopefully someday we're gonna get this. We're gonna hopefully someday be able to import std and just get all of the standard library in. Unfortunately, that doesn't exist yet. Probably won't exist in C++ 23, which is coming out next year, hopefully. Maybe in 26. But yeah, C++ goes under revisions every 3 years or so. The big revision was C++ 11. Anything before that is considered old C++, and people generally don't like it very much. C++ 11 introduced things like range-based for loops, and they added a lot of things and made the language like kind of brand new and nice and easy to write code that doesn't have bugs in it and things like that. You might encounter professors that don't allow you to use modern C++, but it's like, it's been 11 years. Like, it's time. Like, come on, like, learn it, So, use a Z to confuse your teachers. It looks like 2. Yeah. Okay. So what is the value here? So we're passing 1 to square n 3. What number is this going to print out to the screen? Do your math. 4. Okay. What about the next one? Up here. 7. Good. And what about this one? 12. Okay. And what about sine and cosine of 0, 0? See if you remember your trig is correct. It is going to print out 1 because the sine of 0 is 0. The cosine of 0 is 1. Now, I could have done this on one line of code. I could have just been like, yo, return sine of x plus cosine of y. This is option 1. Option 2, be more verbose. I don't really like option 2, but I would probably, if I was writing this, I'd write it as option 1. But I wanted to kind of show you guys that you can have more than just one line of code in a function. Okay. So 7, 12, and 1. Very good, Alessandra. Okay. So let's go through the syntax for functions. So every function is a name. The name of the first function up top there is called square n 3. I apologize, it's not a very creative name, but there you go. The name of the function is called square n 3. And the name is used down here, where you can see we're calling it. Okay. And so we can call the function by giving it the name and then parentheses and any parameters that go in there. Okay. Now, how do we know to pass in one parameter to square n 3? Well, up top here, we have what's called the parameter list. So the parameter list for square n 3 is a list of all of the different parameters the function takes. In this case, it's taking a single floating point number named x. For sine and cosine, it actually takes 2 parameters. It takes a float named x and a float named y. And again, these things don't have to be the names. You don't have to call everything x and y. You can call it Bob and Sydney and Alice, which are the default names when doing like cryptography stuff, right? It's A for Alice, B for Bob, C for Sydney. And then there's always like an Eve that's listening in, the eavesdropper. Okay. I'm just using x and y because I don't have any context for what we're doing here, right? Like why are we doing this? I don't know. I'm just making stuff up. And so in C++, well, in computer science in general, like there's like these, like you might see like int2 equals 5 or something like that. Like if you can't come up with a name for something, like it's either going to be like X or Y. But in computer science, a lot of times you can't come up with a name for something. It's going to be like foo or bar or baz or waz or waz or things like that. These are like default variable names for like, you just like if you just need to like show somebody how to make an integer, like you don't know what the integer does, so you just call it int foo, and int foo equals 42. So here's how you make an integer. Like, you'll see this kind of stuff all the time in computer science. So if I knew what I was doing, if you know what I'm saying, if I knew what I was doing, if I knew what these things meant, these would probably have a better, description. Like this would be like baseballs, and this one would be like soccer ball. I don't, you know what I mean? But we're just doing math, so x and y. Okay. All right. So we have our function name here, and then the parentheses are requirements. Parentheses let you know you're working with a function. And then you have inside of the parentheses, you have the parameter list. A parameter list can have 0 parameters, in which case it's just open close parentheses. It can have one parameter, like we have the float x up top there. It can have two parameters, like float x, comma, float y. Note that some students always try to do this, where you have x and y that are both floats. Nope, can't do that. Sorry, you got to type it out. You have to type float x, comma, float y. You can't do, you have to provide a type for each one. Yeah, and if you don't have any parameters, it would look like this if you had no parameters. Yeah, so that's the parameter list inside of here. Now, this is called the return type. So C++ needs to know what the value you're returning from the function is. And in this case, I'm returning floats. I'm taking floats as parameters and I'm returning floats back out. This does not have to be the case. You can have it take ints and return ints, right? This works just fine too. In fact, all the parameters I'm passing in down there are ints, so you probably won't notice any difference in the code. Yep. So we're only taking in whole numbers now for square and 3. All right, so if you pass in 7, it'll take 7 in. So if you were down here and you said square and 3, passing in 7, then what happens is it pauses main, it comes up to here, and x gets set to 7. Then it does some computations. It's going to square 7. 7 times 7 is 49. It's going to add 3 to it, 52. It returns the value. And then back down here where you had square and 3, 7, it's as if you had put the number 52 in that place. And then life continues on. Okay? So in this, it's going to be constantly pausing main and jumping up here and doing code and then jumping back. And then going to the next one and pausing and jumping up here and doing some code and coming back. Things like that. It might sound inefficient, but computers are rather fast, so it can handle it. It'll be fine. There's also something called inlining that stops it from actually jumping up. But that's more of an advanced topic, so don't worry about that for now. Okay. So we've got the function name. We got the parameter list, which is the things that you pass to it. And you got the return type, which is the thing that comes back out of the function. So if you've ever seen like a function in algebra, like a lot of times they draw like a little machine that takes in an input and gives an output. Yeah, this kind of thing, right? You give input and yeah, like that. Like 3 comes in and it does some math, and then output comes out. Have you guys seen this kind of thing before in like an algebra class? Where like sometimes you draw like a little machine and like there's a conveyor belt coming in and like the numbers come in and then the function does some computations and then the result comes out, that kind of stuff. Yeah. Can you call multiple functions on the same line? Absolutely. So I could, for example, say Bob is equal to square and 3 plus sine cosine of 32.2 and negative 63.9. Sure, why not? Basically, any time you have a function, it can go anywhere like a number would go, right? Because the return type of the function is a number. Now, this won't work if the function's returning a string or something like that, right? But like if the return type of the function is float, anywhere a float can go, a function can go. And so you can have multiple function calls on the same line. You could, call the same function multiple times. It doesn't have to be a different function. So you can square and 3, 1 plus square and 3, I don't know, 99. You guys see that? So basically, this will get replaced by 4. This will get replaced. Oh Lord, whatever the number of that is. I can't do that in my head either. Something. It'll get replaced by some number, and then it'll add them all together and set the value to Bob, and then later on we print out the value of Bob. So there's a difference between printing out a value to the screen and returning a value. Like so in the lab class today, like a lot of students weren't returning a value. What they were doing was they were going C out x times x plus 3. And this code is wrong. Okay? Because C out prints it to the screen, but it doesn't return it back to main. Remember, you have to think of this like in algebra, right? Where you've got Carla Rogers. Okay. That previous picture I showed you, right? a number comes in, then it returns the number back out. If you see out something, that's going to the screen. That has nothing to do with the actual math, right? It has nothing to do with the actual code. If you don't return a value, then everything's going to break, right? So you have to return a value. And now some people will do this, like they'll put like a parentheses around the return statement like that to make it look like it's a function call itself. You don't need to do that. It's kind of a style preference thing. I think it's unnecessary. It doesn't really help at all. But yeah, some people, they'll write like return 0 like it's a function. Like you're calling a function called return. You're not. You're not calling a function. No, it's just returning the value. It's passing the value back out. Okay. Do you only need a closing bracket? Yes, you cannot omit this. Okay, that does not work. You can't omit, even if it's a one-liner, you can't do it because of the definition of a function. If you want to see the smallest function that it's possible to write, you can have auto Sydney equals that. So that there is the world's smallest function in C++. What does it do? Nothing. But it's 6 characters, So yeah, the things that make something a function are the parentheses for the parameters and the brackets for the function body. You have to have those. They're not optional like they are with a for loop or an if statement or a while loop or else and that kind of stuff. Okay, so yeah, and Sydney's actually a function. All it doesn't do anything. What does it do? Nothing. So what does the function Sydney do? It prints out I am Sydney. This is C side 41, by the way. Don't worry about this. Okay, this is a more advanced topic, but yeah, I just kind of want to show you what the minimum function possible is. This six characters, and that defines a function. Okay, so function name, parameter list, function name, parameter list, return type, and function body. Okay. So when you call square in 3, it pauses main, it comes up to here, it passes in 1 for x, then it's going to compute 1 times 1 plus 3, it computes the value of 4, it then returns it back here, and then it is as if I had written the number 4 there. Okay. And it does this for every single function we have. That's how functions work. So, if questions about the float, Bob, what is the difference between 1 and 99? I got confused. I don't know what you mean by what is the difference between 1 and 99. So this is as if let me make it simpler. So this is the same as if I'd written float Bob is equal to 4 plus 7. So this whole line of code here is exactly the same as if I had written float Bob is equal to 4 plus 7. Why? Because square in 3, if you pass in 1 for x, squares it and adds 3, it's 4. And then it adds the result of that to square in 3, 2. So you pass in 2 here. 2 squared is 4, plus 3 is 7. So Bob will be 11. Does that make sense, Hiba? So you can call a function multiple times on the same line. Each time you pass it in, the parameters can be the same. The parameters can be different. It's whatever you want. So you can do some lab time now. And for your lab time, let's do this. Lab time. Option 1. Somebody give me an algebraic expression. We'll do some algebra. Just type it out on, algebra to C++. a squared plus b squared equals c squared. X squared plus 10x plus 5. Square root of x minus 2. Okay, yeah, those are all good. Okay, so x squared plus 10x, oops, x squared plus 10x plus 5. Ditto. The square root of x minus 2. So basically, by what I mean here is that, like, given the following algebraic expression, make a function in C++ that does it, right? It's like, I don't want to spoil this for you, but it's going to be something like x squared plus 10 times x, something like that. And obviously, don't call it square and 3 anymore, right? Like, come up with a better name. Don't call everything f. You can only have one f, okay? And that's in your physics class, okay? So, let's see here. X cubed minus 1. Give me some trig or something like that. Like, give me some, like, you know, sine or cosine. Abs, tau, I don't know. Give me something a little harder. These are all, like, kind of easy. Quadratic formula. Yeah, I mean, I guess. I mean, there's already a standard library function that does the quadratic formula. So maybe something else. You're not going to use f because you have none to give. I'm going to press f to pay respects to that, Alessandro. The natural logarithm of e to the x power. So you're going to return x. Limits. Something like, I don't know, the log of, like, yeah, fine. Natural log of x plus tangent of x. No, this is lab time. It's not gonna be graded. Cosine of x. Yeah, okay, that's fine. All right. Actually, you know, I'm actually gonna do this. Okay. Make a function that takes two parameters, x and y, of type, make a function named summer, takes two parameters of type int. Time 1 through 3, we'll use floats as parameters and return types. You guys understand? So for all these kind of math things, we're going to be passing floats in, getting floats out, because it's kind of hard to work with square roots and natural logarithms with ints. You know, it's like, what's the square root of 1? So, so for number 1 through 3, use floats. Do you guys understand? All the parameters are going to be floats. The return type is going to be float, right? And then for number 4, it's going to be ints. So you're going to take ints as parameters for number 4. If x is greater than y, return x plus y. Otherwise, return x minus y. Okay, so you can put if statements inside of a function. You can put loops inside of a function. None of these 4 are going to require a loop. Number 4 might require an if statement. You could probably get by with using a ternary operator, like the question mark colon thing. The conditional expression, whatever you want to call it. So I think this is pretty good lab time. So I'm going to give you 20. Let's see, this class goes until like 4:30. So I'll give you half an hour to do this. Give you till 4. Then we'll start talking about the homework. I'll give the answers to this. Do the homework. When you solve them one at a time, screenshot them onto the chat channel. One important thing to remember is that all this code goes above main. Up until now, everything we've been doing has been inside of main, right? Now all this code is going to be up above main, and you're going to call it. You're going to define the function up here above main, and then you're going to call the code in main. You guys see the difference here? This defines an algebraic function. It returns x squared plus 3. and then you call the function down inside of main. Okay, 2 different places. One makes it, one uses it. Okay, don't get these confused. I saw a lot of people in the previous class try making functions inside of here, or try calling it outside of main. No, this is the right layout. Okay, so yeah, I think that's good enough for you to get going. Scroll up a little bit. Get into the practice of calling your code. Call each of these at least 3 or 4 times from main. Okay, because you need to get into the habit, like I said, of testing your own code. So you've made a function you think works. So in main, try it with like this value and that value and the other value. Try with 0, try with a negative number, try with a positive number, try with a really positive number. You guys understand? Because again, I want you to kind of get into the habit of like, you write code and you test it thoroughly. So you're very happy with it. You're very confident that it works right. Okay? So try to make sure after you make a function, you're just not like, okay, I'm done, move on to the next. No. You make a function, you test it. You compile it, you test it, you run it a bunch of times. Okay, it works. Now you move on to the next one. Right. Use a float for numbers 1 through 3. So, yes. Number 1 through 3 uses floats as parameters and return types, and number 4 uses integers. Just so that you don't get into the habit of thinking it always has to be a float. You know what I mean? Like you can take anything, you can take a string as a parameter if you want, but yeah, I just want you to understand the function name doesn't always have to be f, the parameter name doesn't always have to be x, the return type doesn't always have to be float. Like you can, you can play with it and stuff like that. Let me delete sending out of here because this is too advanced for you. Okay. Again. All right. That was some fun lab time there. Let's go ahead and do this. So let's clear out this code here. Clear out all this code here and just take it from scratch. All right. So first thing is algebra. All right. So write the equivalent C++ code that will compute from algebra x squared plus 10x plus 5, and we're doing floats. I didn't tell you what function name, so I'll just call it, f. Sorry, f of x. I don't know. All right, so return x squared plus 10 times x plus 5. All right. Sorry, I got nothing better than f of that. That's what mathematicians do, right? Everything's f, everything's x. I don't know. All right. For the next one, convert from algebra to C++, square root of x minus 2. Okay. So this one will also be a float as a return type. I'm going to call this function g again. I'm sorry. It's going to take a float x as parameter, and it is going to return the square root of x minus 2. Next one is the natural logarithm of x plus the tangent of x. Of f, g, h, I guess. So x. This one's going to return the natural logarithm of x. Is that a thing? Plus the tangent of x. What is it? That's to cppreference.com. Let's see here. Okay, so it is. So log is just the natural logarithm. Okay. Okay. And that is that. Make function name summer. Okay, so for this one, it's going to. I didn't say what the return type should be, but if it's going to be taking in 2 integers that are ints and adding them and returning the result, the natural thing is for it to return an integer as well. X, Y. Again, some people try doing this. That doesn't work. You have to give the type on every element in the parameters. And so we can actually do this on one line. I'm going to do this on multiple lines first, just to show you that functions don't have to be single lines of code. So I'm going to say integer t equals 0. If x is greater than y, then t is equal to x plus y. Else t is equal to x minus y, return t. So that's one way you can do it. So you can combine what you know with for loops and if statements. All that stuff can be used within a function. And again, a function is there so you don't repeat yourself, right? And so if you were to be doing this code over and over again, these 4 lines of code, then it makes sense to put it into a function and then just call the function so you don't repeat yourself. Okay. Caesar used the ternary operator. Yeah, so you could do this, or you could do it on a one-liner by saying return x is greater than y, question mark. Return x plus y, otherwise return x minus y. So that is a conditional expression, and this is different from an if statement, because you can't put an if statement into a return, right? You can't like return if whatever, like that doesn't work. Because if is a statement, it's not an expression. Expressions are things that could be put inside of parentheses, right? And you can't put an if statement into parentheses like this. It doesn't work. In fact, it'll say expected expression. And you know, you might try giving an expression. You're like, look, let me give it a sad expression. You know, and C++ does not accept a sad expression, unfortunately, as an expression. So it's a little bit misleading. You know, it'll say expected expression, but you give it, you know, smile, frown, doesn't work. It's not the kind of expression it's looking for. Okay, so you can't put a return statement with an if statement, but you can use the ternary operator. So the ternary operator works just fine here, and the ternary operator is in fact an expression, and so you can in fact wrap parentheses around this whole thing here, and see, it works. So expressions can be returned, statements cannot. Okay. Is there a language that only uses emojis? That, you know, I think there's an opportunity there for you. I haven't seen any myself. Is there? Okay. Yeah, what do I know? All right. So yeah, you can do the ternary operator, or you can do option 2, lots of lines of code. And of course, you do it this way. You do option 2. You do option 2 if you're getting paid by the line of code, which is a terrible, terrible thing that nobody should ever get paid for. But you know, like if somebody offers you like $10 a line of code, you're like, okay, sure, I'll take that. I'll take that deal, you know. And it's your t, then t equals 0, you know, and then well, you wouldn't put this on 2 lines, you know, you would put this onto a new, you know, that's a different line. Oh, even better, there, you know, put the trailing braces, you know, so just space all this stuff out, you know. Yeah, so you can really stretch those dollars, you know. You actually use the ternary operator for the first time at Vargas. That's cool. Yeah, Alan, that looks okay. Your formatting's a little bit weird. So remember I said the name of the function had to be summer. So yeah, you're supposed to call that summer. But you want that indented. The formatting's a little bit wonky there. Just, you know, in the space. Be consistent on your spaces, right? Usually I put spaces around all things. Sometimes I will leave the spaces off like this, like deliberately, because do you see how it kind of groups the concepts together, like in your mind, a little bit better, you know? Like this was deliberate, right? Like you could do this and it's fine. From C++'s perspective, it's the same thing, but like, I did it like this because it kind of goes, like, your brain kind of goes, that's a chunk, and that's a chunk. And it kind of interprets it better that way, in my opinion. I don't know. You could disagree. I don't think we need the parentheses here either, but again, it's one of those things where it's like, you know, I try to write code that is readable. You know, you want code that a human can look at it and instantly understand what it's doing as much as possible. Okay? When Baker went over the ternary operator the first time, I was like, I'm never going to use this ever again. Yeah. Ternary operators are cool. You know, I don't know. I don't know what to I'll tell you. All right. Most of your code up here looks pretty good to me. Yeah, I mean, I wanted you to call the code more than just once, right? Like, so when you're testing your code, you need to get into the habit of trying 0, try 1, try 10, try 15, try 2, try -2, -100, +100, right? So try, you know, all the different edge cases and things like that. Um, don't be the person that tries it once, you get the right answer, good to go, push it, like deploy it live, like don't, you need to get into the habit of you write your code, save and quit, compile it, test the hell out of it, edit it again, repeat, 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 repeat. Then, if it's a homework assignment, you submit it to the input tester, and the input tester tells you if you're doing it right or wrong, and it'll give you ideas for what you're doing right or wrong. If you're at a professional company, a lot of times they will have something similar actually to the input tester. A lot of companies nowadays do something called TDD, which is test-driven development, and they will have tests for your code, very similar to what I'm doing. It's there for a reason, so that you can know if your code's correct, right? It's like, maybe you write some code and you edited somebody's function and you don't know if you broke it or not, So a lot of them will have something similar to our input tester here. But yeah, I don't. This looks terrible. Don't do that. Don't get paid per line of code. If anybody offers to pay you per line of code, they have no idea what they're talking about, or take the job, because you can make a lot of money doing it that way. Just stretch everything out as much as you can. Do we have an assignment for TDD in 40? Usually I cover TDD in 41. But after looking at some of the students in 26 right now that are kind of unable to test their own code and just rely upon my input tester, I think I'm going to do more testing in CSI 40 just to get people more into that practice. Okay. So if you're going to test your code, do cout f of 0. F1, f of 12, -2. You know what I mean? These are floats, of course. So 1.1, -6.9. You know what I mean? So, just try it with a bunch of numbers. Run it through in your head. Try positives, negatives, 0, 1, big numbers, small numbers, 0, 0, 0, 1. You know what I mean? Test the hell out of it. Okay, that's what I really want to emphasize for all of you. Is you really want to test your code and be very happy with it before you move on with your life and before you even submit it to the input tester. Okay, so let's talk about your homework assignment because we're basically out of time. Got like 10 minutes left. So this is a assignment called triangle testing. 2 weeks ago, I gave you some lab time that was very similar to this. I told you it's coming. Okay, so this assignment here is very similar to what we did in lab time a couple weeks ago. A little bit more detail. Okay, so what you have to do is let me just run the example code for you. Triangle reference. So basically, it doesn't print anything to the screen. You just type in 3 sides to triangle. If you type in 3, 4, 5, it tells you what kind of triangle it is. See, before we just said if it was an error or not. Okay, so for before, if you had a -3, 4, 5, that's an error. You can't have any negative side lengths on a triangle, right? And if you have a 0, 0, 0 triangle, it's an error. If you have a 8, 6, 10 triangle, that's also a right triangle. They don't have to be sorted smallest to greatest. If you have a 5, 5, 5, it's an equilateral. If you have a 5, 4, 5, it's isosceles. If you have a 9, 9, 8 triangle, it's an isosceles. So you have to identify if the triangle is equilateral, isosceles, right, scaling, which I think I just call other, because scaling is kind of a weird word that nobody uses outside of math. How would you get to say bad input if you gave it a -1? I didn't do any error checking on the code there. I probably should have. But yeah, just call die, exit. That's something that a lot of students forgot for the triangle testing, which is like they were in lab time in the in-person class, like they're doing all this stuff, and they did this. They said if not cn, cout, bad input, right? Actually, for this assignment, you just print error. But then they keep going. They don't quit the program. So you have to remember how to quit the program. Okay? And there's two ways of quitting the program. The function that actually is for quitting is called exit. And you pass in a error code to go back to the operating system. The error code does not get used by anything by default. So literally, you can type whatever you want in there. The sort of general practice that everyone follows is that if you return 0, no error occurred. If you return 1, that means an error occurred. And there's actually, you can actually type exit failure, to indicate that a failure occurred of some sort. It's not used for anything. It doesn't matter. It won't affect the correctness of your code. It's just sort of a, standard that everyone follows. And if they see you exiting 0, they're going to assume that it exited successfully. And if they see you exiting with 1, which is exit failure, same thing, they will assume that you're reporting that an error occurred. Now, like I said, nobody uses it for anything by default. You can make it use it, but it doesn't do anything by default. So make sure you quit if there's an error. Okay? So exit is how you do that. The other way you can quit is if you're in main, if you just return 1, that returns in, because main is a function. And so when you hit return on main, it bails out. It goes back to the operating system. And whatever number you put in here is the error code that goes back. So this line of code and this line of code are the same from main. Now, if you're in a function up here, return doesn't quit, right? It returns back to main. But when main returns, it goes back to the operating system. Does that make sense? So if I wanted to quit from here, I would do an exit, right? This would quit. Okay, that would quit the code, quit the entire program, right? Whereas return just passes the value back, right? It's like in algebra, you pass a function in, you pass parameters in to the function, and then the function returns the value back out. That's what return does. It returns the value back out to the person that called it. And so the reason why return quits for main is because the person who called main is the operating system. So, in general, if you want to quit, just use exit. Okay. Don't do exit -1. Just either exit 0 or exit 1 is the kind of convention that everyone follows. And everyone knows what exit 0 means. Everybody knows what exit 1 means. Exit 0 means everything was fine. We quit normally. Exit 1 means an error occurred. And there's actually some constants. Exit success, that means everything's fine. And exit failure, that means an error occurred. I would exit with exit failure. This is probably the way that I would do it. Okay. So if they type in a squirrel, then do that. Okay. Now, let's go back. Let's see. Testing that reference. I got a lot of triangles in here. All right. So run it again. So if they type in, so you have to be able to recognize equilateral, which means all 3 sides are the same. And I think, it works with floats, not just ints. Don't make ints. So equilateral, if all 3 are the same. Isosceles is when 2 of them are the same. So if we have, for example, a 5, 4, 5, that's isosceles, but also 4, 5, 5, also 5, 5, 4. The sides can come in any order you want. So be able to identify an isosceles. And again, you just, do isosceles. Now, another mistake that I saw a lot of students making was that, when they determined, on the next line of code, they have, some if statement, they would actually just cout isosceles. No. Couting a string is not what we want to do here. Your function, your triangle testing function, which gets past the 3 sides, should not have any cout statements anywhere in it. okay? Because that's not actually returning a value back to main. We're trying to write a function where you pass in 3 parameters and it passes back is this equilateral, isosceles, whatever, okay? If you see out something, that is not returning it back to main. That's just printing something to the screen. And so a lot of students had this problem where the function was just printing something to the screen and not actually returning a value back, okay? So and I'm not going to give you the code for determining an isosceles because that's your homework, but I can show you what it would look like. Like, let's say this is code that would determine if it's isosceles. What you're going to do is return isosceles. Now, how does that work? Well, I have this thing up here called an enum. An enum is like a bunch of constants. It's as if I had typed, I've got a variable named equilateral of type int, whose value is 0. You get a value named isosceles of type int, whose value is 1. And so this enum thing here actually creates a bunch of constants for you. And they all have different values. And so basically, these are the 5 different values you can return from your function. Equilateral, isosceles, right, scaling, aka other, and error. Okay, so what your code should look like is I've already given you equilateral. You need to write a test for isosceles. You need to write a test for right. Right triangle follows Pythagorean theorem, right? A squared plus b squared equals c squared. Remember, there's the hypot function that will do the Pythagorean theorem for you. It makes it easy. Error. Think about all the different types of errors we talked about before. If a side length is negative, if a side length is 0, if the sum of 2 sides is smaller than the third side. There's a lot of different ways that triangles can be errors. And then if it's none of those, return other. Okay, so if you get past all that stuff and it's just like whatever, you're going to return other. Okay, so that is your only code is going to be like right here. Okay, the only thing in main you're going to mess with is deleting this. You might ask, why did the professor cause our code to just quit? Well, it's so that students who do nothing on this assignment get a 0. Okay, because by default, I think it returns, like like you would actually pass the test. Like if all you did on this homework assignment is just delete this line, like if that's all you did on this homework assignment, you're going to get like 3 points or something, right? Because you're going to pass the test case for equilateral because the equilateral one works. And there's like a couple that are others. So yeah, if you just delete that one line, you'll get like, I don't know what it is, like 2 or 3 or 4 points, something like that. So, if you're busy, just take that line out and do it. I don't want to see anybody getting a 0 on this assignment. Like seriously, like it's just like for every one of these homework assignments, I make it so easy to just pick up free points. Like there's always something you can do that will just give you points like for free with like that. Like that's all you have to do, and you've got 30% on the assignment done. Okay, and so it always like kind of like when I grade it and like people are getting 0s, it's like, how are you getting a 0? Like all you had to do was like that, just delete that line, and you get 3 points. Like that means they did literally nothing on the entire homework assignment, and I'm like, I didn't, these things aren't designed to get 0s, they're not always easy to get 100%, for sure. They're not. But they're always designed so that even if like you're busy and you got like life going on and you got like midterms coming up for other classes and stuff like that, just here, DD, that's the command in Vim, deletes the line, 2 keystrokes, and it'll give you a 30% on the assignment or something like that. Okay. So actually, let's find out how much it is. So compile it, main.cc, input tester. 1 test passed, 2 tests passed, 3 tests passed, 4 tests passed, 5 tests passed, 6 tests passed, 7 tests passed. So it's like 3.5. Okay? So you're going to get like a 35% on this assignment, literally for doing one thing. Okay? Okay? I think that's fair. So if I see a 0 on this assignment, I'm going to take it personally. Okay? Just do that and just turn it in. Like, I don't know. Okay. Are you guys with me on this? I feel like it's pretty reasonable, but it just always seems like there's students that just like don't even, Okay. All right. So that's basically it for today. the code should never say this is impossible, because your code should always be returning either equilateral, isosceles, right, other, or error. Don't see out anything else ever in this assignment. all the C-ins and C-outs are done for you. So maybe you put a C-out or something to like help test your code or something, but like to turn it in, like there should be no further C-ins and C-outs anywhere within your code. Okay? Like it's that part's done for you. All you need to do is delete this one line here, and then write if statements here and figure out what kind of triangle is given to you. Okay? And it can be tricky. Like I said, there's 20 test cases on this one. There's 20 test cases, and because there's a lot of different ways for triangles to be bad. Okay? So it's going to very thoroughly test your ability to write a function to determine what kind of triangle you're given. But I don't think it's too hard. If you know what you're doing, this is probably an hour's work, maybe something like that. Okay. It'll be due at noon in a week. So one last time, upcoming due dates. You've got the competency exam on Monday. The SciBooks on Wednesday. This is due on Friday. And there's no class on Monday. So should be enough to keep you busy, though. Right. It's not too bad an assignment. So that is it for today. Thank you all for coming out. Hope you have a great Labor Day weekend. Have some fun. Relax by the pool. I don't know. Have a good time. I'm going to be playing probably some Path of Exile, doing some board games tomorrow. Might do some fencing. We'll see how it goes. Yeah. C's, open notes, whatever. Just don't cheat. Just like don't talk to other people. Like basically everything I do is like open textbook, open notes, open internet. Just don't. It's not open other people. That's my rule. Okay, so that's it. Feel free to look up things, run it on the server, whatever you want. Okay, I'm pretty mellow. That's it, everyone. Thank you, and I will see you next time. Have a crush-tastic day.